Welcome to the video lesson for 8.2, part 2. Today we're going to talk about the difference between a sequence and a series. So yesterday we talked about a sequence, which we knew was just a bunch of numbers that follow a specific rule or pattern. For a series, we're going to take a sequence, but the difference is we are now going to be adding all the numbers together. So a series is when you add all the numbers from a sequence together. We have this special notation. We've got this sigma here, and this sigma tells us to add all the numbers, so it's a notation when we have a series. The a sub I is going to represent our rule or equation for generating our terms. I equaling 1 tells us the number we're going to start plugging in, and we're going to keep plugging in numbers until we get to n, and then we'll add up all those terms together. So let's look at an example here. For our first example, look here at example number 1, we have the sum from I equaling 1 to 6 for the equation -1 to the I times 5 to the I. So the first part, very similar to what we did yesterday, we're going to find numbers, and we're going to start by plugging in a 1, and we're going to keep going until we plug in a 6. So we're finding 6 different terms, and then the sigma, or the series aspect of it, is going to tell us to add them all together. So let's go ahead and find our numbers. For our first number, we have -1 to the first, which is -1, times 5 times 1, which is going to just be a -5. Then we're going to add to that what we get if we plug in a 2, which would be -1 to the second, being +1, times 5 times 2, or +1 times 10. And then we have minus -1 to the third, which would be a -1, times 5 times 3, or times 15. And hopefully by now we kind of recognize what's happening here. We are adding 5 and then alternating signs here. So we had -5, +10, then we have -15, which means the next one's going to be a +20, and then we have a -25, and last but not least, we have a +30. Those would be our 6 terms. Now what we're going to do is we're going to go ahead and add them together. Now something that kind of helps here, or maybe doesn't, depending on how you look at it, is I've got some opposites here, like -5, -15 will cancel out with this 20. And then 10 plus 30 is 40. 40 minus 25 is going to end up being 15, which is our sum for our sequence here. Let's go ahead and look at example number 2. All right, so now we have, again, a sequence here defined by k factorial. And we're going to find the sum for that series, starting with k equaling 1 all the way to k equaling 5. So for this one, I'm just going to write the notation here. Starting with k equaling 1, we have 1 factorial plus 2 factorial plus 3 factorial. And we're going to go all the way to 5. And now we need to kind of evaluate what our factorials are. We're going to go ahead and use our calculator to do this, but we have 1, and then 2, 3 factorial is going to be 6, 12, and finally 20. And then we're going to add these all together to finish finding the sum for this series. And we get a total of 41 as a sum of this series from k equaling 1 all the way to 5. All right, your turn. Go ahead and see if you can find the terms as we expand this series, or sorry, the sequence of I squared, and then find the sum for that series from 1 to 4. So go ahead and hit pause now, and then try and find the sum. Hopefully you got what I got, which was a total of 30. All right, continuing with this idea, again, we have the same general idea. We want to find the sum for this sequence, but this time we start with 3. So what we're going to do is we're going to start by plugging in a 3, and then keep going until we've plugged in up to 6. So I'm going to start with plugging in a 3, which means what we're going to have is 5 times 3 minus 1, which is going to be 14. And then we're going to add to that what we get when we plug in a 4, which would be 20 minus 1, or 19. Then we plug in a 5, which should be 24. Then we plug in a 6, which would be 29. So I started plugging in a 3, then a 4, a 5, and I stopped at 6 because that's where it next totals stop. And then we're going to go ahead and add these all together, and that will be our final answer. All right, and I got 86. All right, your turn. Go ahead and try and find the sum for the sequence of 3i, starting with I equaling 4, going all the way up to 7, and then check back in to see how you did. Hopefully you got what I got, which is a total of 66. All right, now what we're going to try and do is go backwards. We're going to try and write an equation for our series, which means we have to figure out what I value we're starting with and what I value we end with. For this example, I notice that I start with a 1, and then a 2, and then a 3, and a 4, and a 5. So it kind of looks like we're going in order here. So I'm going to start by writing in I over 7. Make this an I, because again, I'm just plugging in values for I starting with 1. When I go to write my notation, again, the first value that I would plug in for I would be a 1, so I'm going to start by saying that I has to equal 1. And then I keep going until I get a 5, and again, I plug in a 5 into my equation to get a 5 over 7, so I would just put a 5 on top. So for my notation here, we have a sum from I equaling 1 to 5 for the sequence of I over 7. When we look at our next example, we have 1 plus 4 plus 9 plus 16 plus 25 plus 36 plus 49. Hopefully these numbers look familiar. These numbers are perfect squares. So I start with 1 squared, and then we have 2 squared, 3 squared, all the way down to 7 squared. And again, these numbers go in order starting from 1 all the way to 7. And I know that I'm squaring them, so the equation I would use, or the formula I would get to write my series would be just I squared. And I know I'm starting from when I equaling 1. That's how we get 1 squared. And I keep going all the way up until we get 7, which would be 49. And that is the notation for our series. Let's see if you guys can do this one on your own. Go ahead and take what we did for other two examples and try and come up with the notation for the series or the sum of this sequence. Hit pause now and then check back in and see what you got. All right, so the formula I would use to generate my terms would just be I over 4. And that gives me this 1 over 4, 2 over 4, 3 over 4, and so forth. And then I know that I'm starting with a 1, which is why I have an I equals 1 to start with. And I keep going until I get a 4, which is why I put a 4 on top. And we have the sum from I equaling 1 to 4 of I over 4. Taking a look at our next equation, or sorry, next example. This one's a little bit more challenging. We do have a pattern here, but we also have an alternating of signs. I have a positive, then a negative, then a positive, then a negative. And so we're going to have to try and figure out what do we plug in here to make that happen. All right, so let's start with trying to come up with the formula for our pattern here. I know that I have ones on top, so that's pretty straightforward. I have a 1 here. And then my bottom is where the pattern picks up. I have 1 cubed, 2 cubed, 3 cubed, 4 cubed. So that's definitely my pattern here. I'm going to go ahead and put I cubed, because that's the value that's changing. But I know that it's alternating sign, and this is where it gets a little bit challenging. My first number is positive. My second number is negative. So I need to take values of -1 and raise them to an exponent so that I get a positive versus a negative. If it's going to be positive, then I need it to be an even exponent. And the way we're going to do that is we're going to start with an I minus 1 to make that happen. And I'll talk a little bit more about why we do that. I'm going to go ahead and put my notation here for my sigma. I'm starting from when I is equaling 1, and I'm going to stop when I is equal to 5 because my last term is 5 cubed. Now let's talk about this -1 a little bit more. If I start with I equaling 1, and I plug in a 1 here, I get -1 to the 0 power, which we have defined to be a positive 1, which gets me that positive value. If I want to find my second term, which is that negative value, well, that means that I would be 2. And if I plug in 2 for I, then I get -1 to the first power, which is a -1. So I now have established this positive, negative aspect. If my first term was a negative value, then instead of saying I minus 1, I would say to the I power. And that's kind of a general rule of thumb. So if our first term is positive and then it's negative, then we have I minus 1 as our exponent for -1. If our first term is negative and the second term is positive and it alternates, then we have -1 to the I power. All right, let's try another example. All right, again, we see that we are alternating. And hopefully these numbers do look a little familiar. I'm going to go ahead and write down the base for our pattern here. I know we have positive and negative alternating, but I start with a 3 squared, and then a 4 squared, and then a 5 squared, all the way down to an 11 squared. And we know we have this positive and negative thing we'll have to add in as well, but that's kind of the base for our pattern. We're squaring our numbers. So I'm going to go ahead and write down that we have I squared. And then I know that I have to alternate these positive, negative values, and we just discussed this, that if I want it to start as a negative value, then I'm going to have -1 to the I power. If I wanted to start as a positive, then I had -1 to the I minus 1. We're going to go ahead and put in our sum. And this is where our I value is not going to start at 1 because we started with a 3 squared. So I'm going to go ahead and put that this is to the I equal 3 to start with, and we keep going until we get to an 11 squared, so I'm going to put an 11 on top. And we're going to double check something real quick. If I take a negative 1 and I raise it to the third power, negative 1 to the third would in fact be a negative 1, and that gets us this negative 9 at the very beginning. All right, your turn. Go ahead and see if you can apply what we just discussed to come up with the equation for our series of negative 1/2 plus 2 over 2 minus 3 over 2 all the way to negative 10 over 2. Hit pause now and then check back in and see how you did. All right, so my series equation is going to be the sum from I equaling 1 to 5 of negative 1 to the I power times I over 2. So this I over 2 is how I get my 1/2, 2 over 2, 3 over 2, 4 over 2, and 4, so forth. And then I know I want my first term to be negative, so I start with a negative 1 to the I power. Again, if that first term was positive, I would have negative 1 to the I minus 1 to make that positive. Hopefully you guys got this one. Okay, only a couple more examples to do. All right, here we have 5 over 1 plus 1, plus 5 over 1 plus 2, plus 5 over 1 plus 3, plus all the way to 5 over 1 plus 15. To kind of establish our pattern, we definitely have a 5 on top, so that's not going to be changing. And then we have this consistency of a 1 on the bottom, so I'm going to put that. And then I'm adding values starting from 1, going all the way up to 15. And since that's the thing that is changing, that's where my I is going to go. So I have plus I. And then I don't have to worry about positive and negative alternating values, so I don't have that negative 1 aspect. And then my first value that we're starting with is, again, this 1. So I'm going to write down I is equal to 1. And I'm going all the way up to where I have a 15, so I would just put 15 on top, and that would now be the equation of our series. We have one last example to try and get through. We have 3 times 1/5 plus 1 plus 3 times 2/5 plus 1 plus ... Again, we can see some constants here, so I'm going to go ahead and write those down. I know I have this 3 times some expression, and I know I have a plus 1 on the outside. The expression that I'm multiplying by 3 is what is changing. I have this constant of a 5, so that's not any different. And then I'm just going to put this I on top because that is, again, my value that's changing. I start with a 1, and then a 2, ... all the way till we get to a 5. So we have our equation for our sequence. We're now going to go ahead and figure out what our I values have to be. So to get this 1 over 5, notice I'm going to plug a 1 into my I, which means I'm starting with I is equal to 1. And we keep going until we get to a 5, which is not that many terms, which means I'm going to stop at a 5 on top. All right, that does it for our notes for this section. Go ahead and get started on the homework, and good luck.